Okay, today we're going to talk about the different types of reactions and how to figure out which one is which. The first thing that we're going to talk about, or the first one we're going to talk about, is synthesis. Now, synthesis is where you have two elements that combine to make one compound. And this is the generic equation right here where it says A plus B gives you AB. And then I give you a picture of what it looks like at the bottom where magnesium and nitrogen come together to make magnesium nitride. Now, another way to talk about synthesis is thinking about it like a cartoon. Think about if you have a hungry bird and then there's also a worm. The bird ends up eating the worm because it's hungry, and the worm is in the belly of the bird. Okay, so it's like two things come together to make one thing. Now, decomposition reactions, they break substances apart. So it's like the reverse of synthesis. It's when you start with a compound and it ends up breaking into its different parts. Now, I show you how one looks at the bottom where you have calcium carbonate, and then it breaks into calcium oxide and carbon dioxide. Now, another way to think about decomposition, just to try to remember what it's like a breakup. You have a couple here at high school, and they're all lovey-dovey, hunky-dory for a little while, and then all of a sudden something happens and they break up. Okay, so that's like a decomposition. Now, combustion reactions. They always have oxygen as a reactant and water as a product. Okay, I forgot to put that on my slide, so make sure you write that in. Combustion reactions always have oxygen as a reactant, so on the left-hand side, and water as a product on the right-hand side. And as you can see, it gives you the general equation, but I also gave you an example to look at. You have methane, which is CH4, plus oxygen, which gives us carbon dioxide and water, and that's a combustion reaction. Now, we have replacement reactions, and I put single displacement here. It can be single displacement or single replacement. Your book says replacement, so I should have changed that. So make sure you know it's displacement or replacement. And single displacement is when one element changes places. So if you look here, you have AX plus B, so the X is partnered with A in the reactants, and in the products, X is partnered with B. And I show you some examples down at the bottom to show you what it looks like when you have a picture with it, but then also what a legitimate chemical equation looks like with that. Now, a way to remember this, a single replacement reaction, is let's pretend that Mr. Orange Shirt is going to the dance by himself because he couldn't find a date, and the couple dressed in white, they're going together because they're the dates for the dance. Well, by the end of the dance, the couple breaks up, so Mr. Orange ends up dancing with Mrs. White, and Mr. White is headed out by himself. So that's just a way to remember it. All right, double displacement reactions are when you have two things that switch places. So if you look at the X and the Y, where they start off with, who they start off with in the reactants, and then who they end up with in the products. And then there's an example at the bottom again for you. Now, an example or a way to remember this is if you look at the beginning, we have the little boy wearing the tiara and the girl wearing the pilgrim's hat. And at the products, we have the boy wearing the pilgrim's hat and the girl wearing the tiara. Okay, so it's two things switch places. Now, this is what I'd like you to do for your summary. I want you to write down each type of reaction, list the general formula, and then I want you to determine how are you going to tell the difference between them. Like, how are you going to determine which type it is? And everybody can have a different way. That's fine. But I want you to come up with your way on how you're going to tell the difference. And I will see you in class.